Hello. Today we're going to be looking at fractions on the number line. Okay, so we did simple fractions, this one up here, then we moved down to, we've missed that one, and then we moved down to more fractions, and now we're doing fractions on a number line. So if you could get it open as a lesson yourself, that would be really, really fantastic. So wait for it to load. The computer again is working very slow today, so I do apologize for that. First thing we're going to look at is two different fractions that have the same value. Okay, now we have looked at one the last couple of days, which I kept saying, oh, it's the same as this one. See if you can remember which one I was talking about. Hopefully some of you remember that I was looking at halves and quarters. And we said that 2 quarters is the same as 1 half. 2 quarters is the same as 1 half, and you can see it represented here. You can see that 1 half and 2 quarters is the same length on our wall. This is known as a fractions wall. We're going to be looking more at this in a second. You can see the red and the yellow is exactly the same space. 2 quarters is the same as 1 half. We call these equivalent fractions. Fractions that have the same value as each other are called equivalent fractions. So 1 half is the equivalent fraction of 2 quarters, and 2 quarters is the equivalent fraction of 1 half. Let's have a look at some more. So this is looking at a fraction wall, and it's a great way to see equivalent fractions because we can colour them in. So here we're building up our wall. Now we've got halves, quarters, fifths, and tenths. And we can see that 2/10 is the equivalent of 1/5. If we coloured this in and we coloured these two in, they would look the same length. So the fraction wall shows that 1/5 and 2/10 have the same value. They are equivalent fractions. There you go, they've been coloured in for you, so you can see. But we can see that a quarter and a fifth are not equivalent fractions because a quarter is bigger, it's a bigger fraction than a 1/5, and half is an even bigger quarter than 1/5. So we cannot say that a quarter are equivalent fractions. So we're going to add more rows to our fractions wall, okay? We can see working down halves, thirds, fourths, fifths, sixths, sevenths, eighths, ninths, tenths. One of all of these cannot be equivalent. If the numerator is 1, then they can't be equivalent fractions. But if the numerator is different to 1, they can be. So what other equivalent fractions can you spot? You can pause the video if you want to have a look at some of the other equivalent fractions. One that I can see is that 1 quarter, you can see that 2/8, these 2/8, if we drew a line up from here, it would be equivalent to 1 quarter. That's one that I can see. Pause the video and see if you can see any more. So we're going to use the arrows to split the bars below. Remember, you can do this after me on your own lesson as well. So it says use the arrows to split the top bar into thirds. So at the moment it's 1 whole. I'm going to go to 1 half, 3 thirds, 2 halves, 3 thirds. Okay, we've split it. Split the second bar into sixths. Let's look what happens. We can see that the lines are at the same place. 2 sixths equals 1/3. Split the bar into ninths. Okay, we can see that the line is continuing down. 3/9 equals 1/3. But 3/9 equals 2 sixths equals 1/3. All of these 1/3, 2 sixths, 3/9 are all equivalent fractions. And the final one we're splitting into 12. When you see the line continues down, 4/12 equals the same as 3/9 is the same as 2/6 is the same as 1/3. These are all equivalent fractions. Remember, not 1/12 is equivalent to 1/3, but 4 is equivalent to 1/3. What do you notice about the numbers? Oh, come to that in a minute. Now we're looking at 2/3. How many would be sixths? So I've got these two blocks. I'm going to count the sixes. 1, 2, 3, 4. So we know 4 sixths is equivalent. We've got an equal sign here because it means they're exactly the same. Equivalent and equals are the same, mean the same thing. So these are equivalent fractions, so we use an equal sign. 4/6 equals 2/3. Then we're looking at the ninths. So we need 2/3 worth. 1, 2, 3, 4, 5, 6. 6 ninths equals 2/3. And then the 12ths, we're looking to this line here. 1, 2, 3, 4 in 1/3. 5, 6, 7, 8 in 2/3. So these fraction rules are really useful to help us. But you may have noticed something as well, which is what I jumped the gun with. What do you notice about the numbers in these fractions? The numerator 2 times table 2, 4, 6, 8, and the denominators 3, 6, 9, 12. Shout out what timetable that shows. Should shout out the 3 times table. So knowing this helps us find the equivalent fractions. If we know that the bottom number is going up in 3s, we also know that the top number is going up in 2s. Not in all cases though. This is only when we're looking at thirds. Okay, so we can't just say a half and then times it by 3 and 2 at the top, because that wouldn't work. You times the 2 on the bottom of a half by 3, you get 6, and the top number 1 by 2, you get 2, and 2/6 isn't the same as 1/2. So please don't get confused. We can use our times tables to help us, but we must know which ones we're using. So let's have a look. Now, we can use the fraction rule to help us if you want to when you do this, or you can give it a go without using the fraction rule. Okay, so what we do, I'm not going to use this fraction rule. I'm going to take it away. And the reason why is because we're not always going to have a fraction rule, especially not in a test. So we need to know how to work out our equivalent fractions without using one. And this is how. 5 and 10. We can see that we've times 5 by 2 to get 10. And therefore, we need to times 1 by 2 to get our top denominator. Whatever we do to the bottom, we must also do to the top. Always equal. Whatever we do to the bottom, we do to the top. Therefore, if we've times 5 by 2 to get 10, we times 1 by 2 to get 2. Okay. Now I'm going to show you. Oh, gone a bit too far. You can see here 1/5 equals 2/10. Here we times 4 by 2 to get 8. Therefore, we need to times 1 by 2 to get 2. And I can show this again. 2/8 equals 1/4. We've times 3 by 3 to get 9. 3 times 3 is 9. Therefore, we need to times 1 by 3. We're doing the same to bottom as the top. And 1 times 3 is 3. Here we go. We can see it here. Again, we've got 1/3, but this time we've times it by 2 to get to 6. Therefore, we need to times the top by 2. There. Here, we've times 6 by 2 to get 12. Now, this one, we don't have a 1 on top. So 6 times 2 equals 12, and 4 times 2 equals 8. Oh, not 6, 8. And if I put it into here, I'm counting 1, 2, 3, 4. So I'm looking up to this line here and I can count 1, 2, 3, 4, 5, 6, 7, 8. So we can see that those are our equivalent fractions. Half, we know that that is 2/4. We've done that one many times over the last couple of days. So we need to decide whether the statement below is true or false. I'm only going to do 3 of these because I want to move on with the lesson, but you can answer all 10. True or false? 1/3 equals 4/12. So we've times 3 by 4 to get 12. 3 times 4 equals 12. So it is 1 times 4, 4. Yes. Okay, so I would say from looking at this, this is true, but we can also type it into here, thirds, and we can go up to 12s. Gone a bit too far. And we can see 1/3, 1, 2, 3, 4 12s. True. Okay, I'll do 2 more. 4 times 2 equals 8. 4 times 2 equals 8. So we've times the bottom by 2, so we must times the top by 2. And I can see that 3 times 2 is 6. So I know this one must be true. Again. 1, 2, 3 at the top. Looking at the line here. 1, 2, 3, 4, 5, 6. True. 5, 6, and 3/9. 6 times. Oh, can we do that? 6 times what equals 9? It doesn't go. Okay. So what I'm going to do, because I can't times the numbers, I'm going to look on here and see whether it's the truth or not. 5, 6, 1, 2, 3, 4, 5. I'm looking at the line here. Now I can already see that it would be halfway through a 9. So it cannot be true. Okay, 3/9 is only here. It's down here. Whereas 5, 6 is up here. So we can see that 3/9 is a much smaller fraction than 5, 6. Incorrect. So have a go at the rest yourself on your own lesson. So we can think of fractions as numbers on a number line. So we all know what number lines are. We use them a lot in school. So here we have a number line from 0 to 1. Now remember, if the denominator and numerator are the same, it is 1. Therefore, we have a number line from 0 to 1 split up into sixths. We can it can help us tell which numbers are biggest and smallest. The further to the right, the further this way, is the biggest number. And the further to the left is the smallest number. Smallest fraction. But it's not a whole number. So here we can see if we split this line into 4, okay, what 0 to 1, then what would each of these be? Can be marked in quarters. Therefore, where would 2 quarters be? We know this is 1 quarter. We know this one must be 2 quarters. And I can check that by knowing that that's half and that's half. And we know that 2 quarters is the same as a half. What about 3 quarters? Again, I will count 1, 2, 3. Okay, so 1 can always be thought of as a fraction. It can be 4 4s, 6 6, 12 12s, 100 100ths. That always equals 1, as long as the numerator and denominator are the same. Number line can be marked to show any fraction. As I said, hundredths, it could be marked in hundredths. This one is going to be marked in tens. Okay. So these children are counting up in tenths, and we can see that the numbers are going on. And this one, remember, if the numerator is smaller, it's a smaller fraction. If the numerator is bigger, it's a bigger fraction. We can see here that 9/10 is longer than 7/10, so it's a bigger fraction. We can see that 3/10 is shorter than 5/10, so it's a smaller fraction. Computer. Okay, so The number line below marks each to show a different fraction. You can see the little lines to show how much the number line has been split up into. What I want you to do is pause the video and match the correct fractions and then see if you got the same as me, or do it afterwards, please. So this one we can see is split into 1, 2, and we know that it's not called twos, it's called halves. We can see this one is split into 1, 2, 3. It must be thirds. 1, 2, 3, 4 quarters. Oh, my thirds didn't go in. Oh, it went into the halves. 1, 2, 3, 4, 5. We can all see where this is going. 1, 2, 3, 4, 5, 6. Sixths. Now this one isn't sevenths, it's 1, 2, 3, 4, 5, 6, 7, eighths. Okay, that's why it's important to count. I know we don't have a seventh here, but we need to count it anyway. 1, 2, 3, 4, 5, 6, 7, 8, 9, tenths. And therefore the last one, which is the smallest divisions, you can see that they're smaller, so they must be 12ths. So, final slide of work. We can drag the slider to mark the position of each fraction. Now we've done this one, 3/4. Okay, there are 10 questions in total. I'd like you to try them all. I'm going to do another 2. 1/4. We can just count 1. Oh, this one's interesting. 4/4. We know that if the numerator and denominator are the same, then it's going to be 1. I'll do one more. Waiting for it to swap. That's better. Okay, so final one, 8/16. Now I already actually recognise that 16 is double 8, and therefore I know that this must show half. But you might not have noticed that, so what you should do is count up 1, 2, 3, 4, 5, 6, 7, 8. Now you can actually see that that's half, but don't worry if you didn't see that. All you needed to do was count up the number line. We're going to do one final one. 13/16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Good. Okay, so enjoy working on this lesson, and then enjoy going into your portal and doing your work that I've set you. And I'll see you tomorrow for our final fractions lesson. Remember, we're not having a lesson on Friday because it's bank holiday. So I'll see you tomorrow for our final fractions lesson. Have a lovely day.